So now you may know that our solution just now is causing a n squared runtime. And you may be wondering if there is a better solution to this. And this is something you actually should do when you are going to actually your upper division courses or an interview for a company, that when you have a solution or a naive solution, you always want to ask yourself if there is a better runtime solution or a better algorithm. So in this case, let's think about it. So we just know that there is a specific attribute of our input that our array is sorted that we did not use. Will that be handful? And yes, and that will help us to largely decrease our runtime. So since our array is sorted, for example, we have 12. All right. So now we know that everything in the start is small, and everything that is at the end is big value, right? And it's sorted. Therefore, if we always look at the first and the end, or the start and the end, I want to say, okay, if it is 12, obviously it's not right now, it is 11. And we know that 11 is less than 12. Then what do we do? Should we move this pointer P1, or should we move this pointer P2? If we move P2 to the left, that will decrease the value at the end, and therefore will make this value even smaller. On the other hand, if we move P1 to the right, that will increase the value, and therefore make this value bigger. And that's how we're going to solve our question. We're going to keep moving this pointer 1 and pointing 2 until we get to the specific point or the specific value we want. And if when P1 and P2 meet each other, we still didn't have anything, that means we are not having any match. We are not having any match in this input array and should return false. All right. So that being said, so first we can again create a public boolean sum2, but this time sum fast2. All right. And it's taking in, again, two arguments, an integer array ARR and an integer x. All right. I'll move this a little bit here. So what do we do here? So first we need to have two pointers as we saw before. And since this is an array, the pointer of an array is actually just the index itself. Therefore, we're going to have int front equals to 0. Oops. And then we have int end equals to ARR.length. Remember, you need to -1 because it's 0 indexed. And now you put while front is not equals to end, which means the front pointer and the end pointer is not meeting each other. On that case, we should do something. What should we do? We should first check if my value right now is equals to my target value. All right. So I will say int temp sum equals to array front plus array end. And I will say if temp sum is equals to x, which means it is exactly the value that I want, I can directly return true. If it's not, then we're going to do something. What are we going to do? We're going to say, we're going to try to figure out, should we move the front pointer to the right, or should we move the end pointer to the left? Or should we increase the front, or should we decrease the end? So let's say if temp sum is bigger than x, then that means our sum right now is too big. We want to decrease it somehow. To decrease it, as we saw before here, we should move the pointer to or end to the left to decrease the sum. Therefore, we will move our end -1 or end minus. Else, that means our temp sum is too big or it's too small. Then we're going to increase the front by saying front plus. And if after I do all this while loop and never reach a point that the temp sum is equals to x, we will return false because there is no such matching two numbers. this is a new algorithm. And what is the runtime? So as you see, the runtime is, or what is causing a runtime, or what is causing the work here is just this while loop. And we will terminate the while loop when front is equals to end. And therefore, when front is equals to end, we will only traverse this array one time. And that's because no matter if we move this, this front to the right or if we move end to the back, they will meet the moment that they touch all the element in this array once. And you cannot go over it, and you will not. And therefore, all we are doing work here is theta n, which is just the length of this array.